Sci Access, May 11, 2024. Access to the Analog, How Analog Astronaut Experiences Are Becoming More Accessible. Dr. Sheri Wells Jensen, Sheila Shu.
Hello. Hi, everyone. I'll go ahead and introduce myself. I am Sheila. This is my name sign here. It's an S on the side of my cheek. I work for Astro Access, and here's the sign for Astro Access. I am actually the Deputy Director of Development. Also, I'm doing a graduate student and 2 master's degrees. So currently, I have the master's degree program. There's 2 of them. I'm doing a public policy, and that's at Harvard University. And also the MBA of Business, which is at Wharton. That's under the University of Pennsylvania. My area of interest, my field is multimodal communication in human systems. Astro Access tends to have, there we've got some fireworks going off here. Okay, multimodal communication means that typically there's a radio for a communication, but we would like to expand our access, have as many different communication modules as possible. So trying to figure out how specifically deaf and hard of hearing people can become astronauts. How can we become involved in human and space and be involved in NASA space missions?
Okay. There. Hi, everybody. Is this working now? Are we being sensibly audible and everything's good?
Yeah, we are looking at your screen share. We can hear you. That all sounds good.
Fantastic. Sheila, thank you so much. And I'm very sorry. Hi, everybody. I'm Sheri Wells Jensen. I'm one of the flight ops leads at Astro Access. Thank you, Sheila, for the introduction of what Astro Access is. What we're going to talk about today is access to the analog. And for those of you who are not familiar with this wild, amazing thing that is done in the aerospace community, an analog is a setup where you basically mock up everything that you would do in space with the one variable that you're not in space. So if this is a great way to test equipment and procedures and crew configurations and everything else you need before you go into space, because you don't want to be testing those variables while you're flying, right? You don't want to be halfway to the moon trying to figure out how things are going to work. So you just try to do everything you can do in advance. And one of the current variables that we're very interested in is, what do we do? Can we, and how do we have disabled folks in outer space? How do you break that last ultimate glass ceiling and make it so that a disabled person can be a scientist who also becomes an astronaut who goes to the moon and does whatever we need to do, right? So we don't want to just throw disabled people into a situation without doing the support research that is necessary to make sure that there is success. We want to do the research that we need to do to find out what disabled people need on these missions to make sure that that they can be full and equal trusted crew members. And again, we're not talking about educational stuff. We're not talking about simulations to improve people's whatever confidence, anything like that. All that stuff is good. What we're talking about here is NASA level kinds of investigations where we really will find out what disabled people need to go into to go and be astronauts, to really do those jobs. Let's see, and I'm going to just keep calling next slide, and whoever is advancing the slide, my apologies, but just keep flying along with them, and we'll hopefully sync up. So lots of disabled people have been on analog missions. There are about 24 analog sites around the United States and around the world. And this work has already begun. We have had all kinds of folks in analog missions, people with ADHD, people with various degrees of blindness, some folks who are blind and hard of hearing, PTSD and anxiety, learning disabilities, folks with OCD, folks with a single lower limb prosthesis, and wheelchair users. All of these people have proven that they can be equal and trusted crew members at the analog level. We most recently had a disabled person in a wheelchair, Michi, run as a crew commander over in a 2-week analog in Poland. So we're at the lessons learned stage. So what have we found out with all this investigation that we've done? First off, there is no reason to continue to build habitats that are not accessible. Some are accessible and some are not. We don't need to mess around with inaccessible habs anymore. Next slide. You can make a habitat accessible with high-tech solutions. We have a picture here of Andy Squires, who was one of our blind analog astronauts in Arizona. And you can also do that with low-tech solutions, like literally sticking Braille labels on things. It's really important, next slide, that we communicate, make sure that everyone knows what everybody needs. That this is again a picture of Michi, who is a wheelchair user, doing her analog. We have a couple EVAs and people they go ahead and just put on the spacesuit and step outside as though they were on Mars or on the moon. There is pictures here of me with my white cane walking around a simulated Mars environment. It's really important that we keep in touch and share information as we go also. Sheila is here to talk about her work in training as an analog astronaut. We've not yet had a deaf person as a whole analog astronaut, but we are going to make that happen for sure. Sheila, would you like to talk to us about what you and Eric did and how it contributed to inclusivity of the analog mission?
Sure. Certainly. Do you mind going ahead to go to the next slide, please? Okay. So in December of 2022, I had zero gravity, one of those parabolo flights, the parabolic flight. It was myself, and there were 3 other deaf and hard of hearing people. We became the crew. There was 4 of us. And there was one other gentleman with me by the name of Eric. And the 2 of us were specifically responsible to run an experiment to see if all of us, the crew members who are deaf and hard of hearing, could communicate via American Sign Language in a zero gravity situation with kind of the abnormal positions and how we would float around. About a month before that flight, we were in Arizona. And Arizona is where Biosphere 2 is located. And the University of Arizona has a pool, and that pool was the perfect place for us to go and test out and run our experiment because all of that happened underwater. And that's the picture that you're seeing on your screen here today. That is both me and Eric, and we're underwater here. And we did learn that in this underwater experiment that we could see and communicate with each other via American Sign Language underwater. And next month, we're going to go to Houston, Texas. All right, we're just going to give it a second for all of this to catch up. And there we go. Oh, I see that I'm spotlighted now, so it just took me a second to adjust my screen. Yeah, the month after that, went to Houston, Texas to go ahead and run our experiment in full zero gravity. This is much different than the underwater experiment. You know, underwater, we had all of the equipment. So we had the oxygen masks, all of our big bulky suits, our helmets. But when you're in zero G, you don't have those specific equipment, none of the clunkiness. We did have a Go React camera, which was placed on our foreheads. And we realized with the results of each other that we could understand communication modality as long as we maintained eye contact. As soon as we were looking away or floated off, then we could no longer understand each other. But as long as we maintained eye contact, we could understand and communicate with each other. And so that experiment has already been run, and that's finished. And there's another one, which is involving my favorite activity. You'll see that on the slide soon. This is sign language communication with a spacesuit. Oh no, I thought that was going to be, do you mind going back to that slide? I thought that picture was going to pop up. Go back to the previous slide, please.
It seems that the video is not playing on the slide. Do you have it saved, perhaps, Sheila?
Oh, it's not a video. It was just an image.
There is unfortunately nothing showing on the slide.
Okay. Oh, well, we're just having a few technical difficulties today. That's okay. I'll go ahead and explain what that looked like. So Eric and I, we loved the opportunity to go to Biosphere 2. We would do anything that we could, and that was using the space suit, and being in a pressurized environment. So there we go. That's it. Yes. Yeah, that's the two of us. So we're in that pressurized environment. That's a huge challenge to get everything on. You actually need two people to help you enter that suit. And then you add gas, and the gas in the suit does help the suit pressurize. The two of us were trying to see if it was possible that even within this bulky equipment, could we still understand each other? And we found that yes, we can still understand each other. The gloves, they're really thick, and they're very stiff. It's hard to maneuver, but we could still understand each other's communication. Even with finger spelling and signs, specific signs and facial expressions. So my vision and my hope for the future is that space equipment can become more thin. And still be able to maintain the gas pressurized environment. That pressure, it within the gloves does tend to make them very rigid. But I believe that this was the first time that we could see and really show that a spacesuit was able to you were still able to communicate in sign language. So I think the two of us were the first ones that were able to do that so far. Additionally, I mean, this is very important. So you can see that the spacesuits, we saw that it does is effective for sign language, and in the future, we do hope to complete spacewalks. Making sure that we can find the right tools. If the sign language can work in an astronaut suit for deaf and hard of hearing people, that means that we can have the opportunity to go to space. I guess we can go ahead and advance to that next slide, please. Yeah, feel free to contact any of us if you'd like some more information. The links are there. And now I'm just going to kick it back over to Sheri if you have anything else that you'd like to add.
No, I think you did great. Thank you so much, Sheila. The most important thing that we want to say is that this is happening. It is cutting edge in the aerospace industry, and that one of the most important things is that we keep in touch with one another. If you've been on an analog, we need to know what you've done. We are still learning what things have been done and are being done in analogs. There's much more going on outside even of Astro Access, and it's important that we all share information and learn from one another and share our information in a central place so that we can make appropriate advancements. And thanks, everybody. I know we're a little bit late.
Thank you so much to both of you. And we actually did just hear from our next speaker, and they unfortunately will not be able to make their time. So I know that we had quite a few technical difficulties. If you two would like to take some extra time and go over any points that you feel you missed, or we can go into Q&A.
If we do have 3 minutes before Q&A, that would be fantastic. I think the key thing here is that we're talking about we're not talking about the abilities of the disabled person, because we have shown on Earth that it is quite possible for a disabled person to be a master of a STEM field. So that's not the question here. The question is, what are the modifications to the environment that we need to make, both at the high-tech engineering level and at the very basic level, to make a person successful in an outer space environment. A space vessel is just a room. It's a fancy room in a very dangerous place, but it is just a room. And we know how to make rooms accessible. So we know how to make laboratories accessible. The last speakers made it pretty clear to us that that's not always done, but it's certainly quite possible to make any science lab accessible. We just need to work on it. And again, we're not changing the person, we're modifying the environment that that person is in so that the job can be done. And the goal, again, is not just to fling a couple disabled people into space and go, yay, we did it, we were there. The goal is that anybody on the planet who needs to or wants to go to space at some point can be a full, trusted member of the crew and get their job done. Whether their job in space is to float around and be a tourist and have a nice time, or whether their job in space is to command a crew like Michi did. We want to make sure that that can happen, and we want to do the supporting research before the people get there so that it's clear to everybody that once you get into space that you will be able to do the work that you are called to do. I think both of us would be happy to take questions.
Absolutely. Thank you so much for that, Sheri. That's a really good way of putting the work that Astro Access is working on and that you are working on. We do have quite a few questions for you here, beginning with Jake, who asked, do you think with the gloves, stiffness would be okay for ASL if you were on the moon, for example, where you would also have a lot of sun shield, so you might not be able to see the facial expressions?
Sure, I'll go ahead and respond to that. Well, there's only one way to find out. Actually, the goal would be to have an analog, an analog astronaut have the opportunity to do that kind of test environment with the sun shield, and then see. Right now, it's not clear. That's possible. Maybe not. Well, we'd have to see and check to see if that's a possibility. Really, the point is we do need to have deaf and hard of hearing people be involved in analog astronaut technology. That's the only way that we're going to be able to find out the answer to that question.
Thank you so much, Sheila. I'm really excited for the first day where we get to see a deaf person on the moon, and then we can get a real answer to that question. We have another question from Alberto saying the Marvel TV show Echo had an example of projected signing hand images interpreting for the speaker. Does that technology really exist, or is it in development?
I have seen. I did watch the TV show Echo already, and when I saw that technology, that did provoke a lot of thought and consideration. It's almost an easy cop-out. The guy that was her uncle in that show, Kingpin, right? He didn't have to learn sign language because he depended on AI technology. So do I know if they have the technology now? No, I'm actually not sure. I don't know if that technology is available, but I have my doubts. And I don't think they have that technology at the moment, but that's a simulated science type thing. It was interesting to see that. So Echo's uncle didn't have to learn sign language, just depended on the AI technology. And this is the sign, this is the name sign for Echo. It's like sparkly off of the cheek.
Actually, my training is in, that's where my PhD is in linguistics. And so I'm getting, no, that technology, Sheila is right, that technology is not readily available. And more than that, nothing can replace the human mind and brain when it comes to language learning. And we can work really hard and get great technology, and then all of a sudden that technology can fail. Everyone who's had their iPhone battery go dead when they really need their iPhone knows that technology has its limitations. What does not have limitations is the marvelous human brain. So there is no substitution for bilingualism. There's no reason why folks who are training together can't share a language. And if that language is ASL, that's fantastic. And we should just do that. We put up, as hearing people, we put up a lot of barriers in our heads about, oh, we can't learn that. But we absolutely can learn it. There's no reason not to learn it. You can do anything in ASL that you could do in any other language. And so there's no reason not to just have bilingual crews.
Thank you so much to both of you. And I love Alberto's message in the chat of yay to Amanda and Jesse, who are our sign language interpreters. We have another question from Adrian asking, are any analog sites being designed specifically for people with disabilities?
No, and I think that's a good thing, because we don't want to fall into a situation where disabled people are relegated to one analog. I don't want to be told that's your special analog, go there. But we do know that increasingly, maybe I should not say increasingly, but we do know that, for example, Lunaris in Poland is pretty wheelchair accessible. There still are, maybe not perfect. So that can be done. Traditionally, analogs have been built kind of with stairs between the levels. I don't know, they're rocket ship shaped. I don't know, maybe people think that's cool. The new one that they've built within NASA is not wheelchair accessible. And so I think that our approach needs to be, let's quit building these things that are not accessible to everybody. Let's build in the technology that everybody needs everywhere from the ground up. And if we can do that in space, which we can, then we can start expecting that same level of inclusion on Earth. That's part of the goal here, right? I mean, we want people to go to space and we want disabled people to rock the moon. Absolutely. But the moon is very small and most of humanity is going to stay on Earth. So we want to rock the moon. Yes, let's do it. But the purpose of rocking the moon, one of the main purposes, is that that technology and that understanding of how things should be falls back to Earth. So in making space accessible, the goal is also to make Earth accessible.
I love that. Thank you, Sheri. And we have a wonderful comment in the chat from Lauren saying astronauts on the ISS are already required to learn Russian. So there's a precedent for learning languages to share communication. No reason it can't be sign language. We have
100%. But I would also add that maybe we're learning ASL. If we want blind and deaf folks to communicate with one another, we might want to consider something like protactile. In addition to ASL, so that we don't have the situation where when Sheila and I are together, we have to have, I could learn to sign, and so Sheila could understand me, but I can't understand Sheila because I can't see her hands and face moving. So there's still some work to do there.
Yeah, absolutely. We have one last question from Kimberly saying, does going to space pose significantly higher risks for cochlear implant users? How are those risks mitigated?
I'll go ahead and take that on. So any research related to a deaf and hard of hearing population and human space astronaut. Just let you know that that abundance of literature is not there. It's very little. So we maybe only have 3 or 4 deaf individuals that have been involved with any of that research that's related to, space travel. So what are the risks involved with a cochlear implant? Really unsure. We would need some more in-depth research, some experimental design, and then actual real implementation. So if you have some interest in that, I would love to see that happen. And so I do have some personal experience. I've had a cochlear implant. I did learn both oral, so I could speech read, sign language, and then a bit of hearing as well. So if I were to meet a hearing person who didn't know sign language in that particular quiet environment, as long as there was no background noise or any additional people, if it was a one-on-one situation, I would be able to respond back and hear and understand them. If the background noise was too loud or there's a whole room full of people, it's too much to speech read, it would become very exhausting very quickly. So definitely would need to utilize on a sign language interpreter and communicate in ASL. And I think to backtrack, I do remember this December 2022 zero gravity parabolic flight when we were looking at access to ASL in those kinds of odd positions that you're in. This could kind of be related to the experiment, right? So there's 3 individuals, all 3 of us were female. We did depend on both ASL and speech reading, and we used some software that could kind of convert what was being heard into almost like a speech to text into an iPad that would clarify the sounds that we were hearing. If there was a specific tone or a pitch or any kind of richness of the texture of sound, it could be converted into something visual that we could see. Because, in those environments, it's very noisy. I was unable to hear anyone. With the helmet on or the spacesuit on, but with the software that's able to convert those sounds into something visual, it helps to be able to understand that a lot better. I guess now to circle back and answer your question, how much risk does it pose to have a cochlear implant in space? I'm not sure, but my gut reaction would say, I don't think so. No.
Thank you so much, Sheila. I really appreciate your insight, especially coming from someone who has used a cochlear implant before, and I'm sure our audience member does as well. We have had a lot of questions, a lot of interest in the work that you and Sheila are doing. We have a couple of just comments of you may be very excited about the new SpaceX EVA suit for signing opportunities. Please contact us at Chasm. Says Axel Trekod, who is one of our other speakers. And then we've had a lot of really great engagement in the chat. Thank you so much to both of you. Are there any final words you would like to share before we move on to our next event?
Just thank you so much. And again, one of our main calls to action here, beyond sort of the abstract call for more research, is that we stay in touch. And that we learn from each other, and so that we don't duplicate effort. If someone has done an experiment, we all need to know about it.
Sci Access. Learn more at www.sciaccess.org.